All right, as part of the pre-IB and pre-AP class, one of the things that I'm going to expect you to do is to be able to take a written formula or equation just like this one and turn it into an equation that has the symbols written down where it's ready to use for what we're going to do today, which is stoichiometry. Okay, so I'm going to go ahead and take you through the step-by-step process. It can be overwhelming, but I promise you that this is already something that you know. It's probably not going to be your favorite thing to do, but it's certainly something that I truly think you are able to do, and I'm expecting you to. Okay, so let's go ahead and take a look at what's written here. It says iron 4 sulfide reacts with oxygen to produce iron 3 oxide and sulfur dioxide. Okay, so the very first thing you want to do is figure out what compounds are given to you. So the first one I see is iron 4 sulfide, and then I see the word reacts. When I see the word reacts, it's more than likely going to be telling you that you're adding it to some other substance, right? So it's plus, and then it's being added to oxygen. So we have iron 4 sulfide reacting with oxygen. And when you see the word produce, if you recall from learning about equations, that would be the little arrow. And then what does it produce? It produces iron 3 oxide. Okay, so definitely one of the compounds we're going to have. And for the word and, it's going to be plus, and then we have sulfur dioxide. Okay, so pretty much what we're going to have is what you see right here, but it's nice and typed. Okay, so we have iron 4 sulfide, oxygen yields iron 3 oxide, sulfur dioxide. Okay, so now the second thing you want to do is to determine what rules will follow when you're writing that the chemical formula for that particular substance that's provided. So the question is it ionic? Is it covalent? Is it a diatomic molecule? Is it an element? So a couple of things to remember. Okay, so I'm going to write it here on the right hand side, but if it's ionic, I don't know if you remember, but you have a metal plus a nonmetal. Okay, and when things are covalent, if you recall, you have two nonmetals. And when something is a diatomic molecule, well, we know that's covalent, but it happens to be these 7, and I'll just put an M right there, but it happens to be these 7 molecules that cannot exist by themselves, and that includes, for example, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, so that's our total of 7. And then the other thing is it just a plain old element? Okay, so that means it's not bonded to anything else, and it's not a diatomic molecule. Well, let's go ahead and figure it out. So the first thing we see for the first compound, it says iron 4 sulfide. So iron happens to be a metal, and sulfide, which is derived from sulfur, but sulfide is just telling you that it's an ion, it's a nonmetal. Okay, if you look at your ion sheet, and you'll have a resource available for you in your Schoology page, but if you look at iron, the symbol for iron is Fe, and this Roman numeral, if you recall, is a +4. Okay, and then it says sulfide. So sulfide again comes from sulfur. The symbol for sulfur is S, and it's a -2 charge. Okay, for ionic compounds, we crisscross the charges. So that 4 will crisscross here, and that 2 will crisscross there. That would really mean that we'd break it down a little bit more. So this 2 and this 4 can actually be simplified a little bit further, and it can be simplified to 1 and 2. So it's going to be Fe1, which we don't show the 1s, and S2. Okay, so that's our first compound written as a formula. And then it says plus oxygen. Okay, so notice that oxygen, and I'm going to go ahead and point it out here on the left hand side. Oxygen happens to be one of our diatomic molecules. It's not paired up with anything else. It's just oxygen on its own. So it's going to be O2. Okay, then we have our little arrow for produce, and then it says that it produces iron 3 oxide. Okay, same thing with the first one. Iron is a metal, oxygen is a nonmetal, so this is ionic. So we're going to have to find the ions. So iron, is a positive 3 because it's a Roman numeral 3. And then oxygen, just like we've done in the past, is negative 2. Okay, we're going to crisscross. So the 3 comes here, the 2 comes over here, and when we write it down, it is Fe2O3. Okay, and then we get our plus sign, and then it gives you sulfur dioxide. Okay, sulfur dioxide. Notice that sulfur is a nonmetal, and then there is no such thing as dioxide on the periodic table, but we do notice that it has a prefix, the prefix of di. Okay, so oxide comes from oxygen, which happens to be a nonmetal. So this is really a covalent. And if you remember about covalent compounds, remember that the prefixes have to stand for a specific number of atoms, right? So for example, and I'm writing it on the right hand side, mono means 1, di means 2, tri is 3, tetra is 4, penta is 5, hexa 6, hepta 7, octa 8, nona 9, and deca 10. Okay, so since sulfur doesn't have a prefix, we can naturally assume it's just going to be sulfur, and there's no crisscrossing in this situation. And this one does have di. Remember here, if you look over here, di means 2, so it's telling you that it's 2 oxygens, just like this, so it's dioxide. Okay, so now we have our equation fully written with all the symbols, and that's a process you needed to take. The last thing you're going to do is you're going to go ahead and balance it. And yes, this is something that we've done in the past, so it's pretty much not new, right? Okay, so to balance this, you always start with your metals and nonmetals and hydrogens and oxygens. Okay, so for iron, if I look at the reactants, notice that it doesn't have a number here, so we really understand it as being 1. And over here, this iron, you see that there's 2. Okay, so if this is 2, my question is, how do I make this into 1? Or to 2, I'm sorry. So I'm going to go ahead and multiply the coefficient 2 by this 1 to make it 2 irons. So if I think about it, iron on my reactant side is 2, and iron on my product side is 2. Okay, so those are good. And now I'm going to go on to the sulfur. Well, because you have a coefficient here in front of iron sulfide, it really affects the entire compound of iron sulfide. So this 2 is also going to go ahead and multiply against the subscript 2 for sulfur. So for sulfur, and I'm going to write this down, 2 times 2 is 4. Okay, and that gives me 4 sulfurs. And if I look at how many sulfurs I have here, well, there's not a coefficient, so we're not multiplying it by anything. So for sulfur, we only have 1. But here's the problem, they don't match. So I can put a 4 here, so it can multiply and give me 4 sulfurs. And that's exactly what I'm going to do. So now the last thing, which I'm going to tell you, is probably a little challenging, because oxygen, you'll see on the product side, it has 2 areas where oxygen is found. It's found in iron 3 oxide and it's found in sulfur dioxide. So we have to add those 2 together. Okay, if we look at the oxygen here, we can just say, okay, there's 2, there's no coefficient. And then let's take a look at the oxygen here. Well, right now we have 3 and there's nothing here, so it's just 3. But we also have to add it to what's here. Remember, there's a coefficient in front of sulfur dioxide, so we're going to multiply that 4 by 2 to make it 8. and we're going to add those 2 oxygens, and that's going to give us a total of 11 oxygens on the side of the products. Here's a problem, that this is a 2. So if I wanted to make this into 11 oxygens, I couldn't, because there's nothing that 2 will multiply to make 11 without me using either a fraction or a decimal. So the key thing here is I want to make sure that I don't have a number that ends up being an odd number. So what's throwing me off here is that 3. As long as I have that 3 and there's nothing here, then that's going to tell me that it's going to give me an odd number. And here's what I'm going to do. You're not going to like this idea, but this is exactly what we need to do. So we're going to have to start all over. So I'm going to erase these. And again, you're like, why would you make me go through this? Because sometimes it happens. I wanted to give you something a little bit more complicated. So I'm going to erase this, I'm going to erase this, and I'm going to start all over, and I'm going to tell you, well, if I had this that's throwing me off, I'm going to multiply it by a number to make it an even number. So I'm going to multiply it by 2. By doing that, okay, now I'm going to look at everything more closely. This 2 is going to multiply with this 3 to make it 6, and it's going to multiply with this 2 to make it 4. But I'm going to start with what I told you, the metal first. So I'm going to say I have 2 irons, which I do. And on this side, notice I only have 1. So my question is, how would I make it into, sorry, I said 2, but I really meant 4. How would I make this into 4 irons? I'm going to go ahead and put a 4 here. And by putting that 4, it's multiplying by that 1. So it's also going to give me 4 irons. So the irons are balanced. Okay, we then went to the sulfurs. Okay, sulfur, remember, is in iron sulfide or iron 4 sulfide. So it's got to multiply with that coefficient. 4 times 2 is 8. So that gives me 8 sulfurs. And then if I look over here, I only have 1. So the question is, how do I make it 8? So I'm going to multiply by a coefficient of 8. 8 times 1 is going to give me 8 sulfurs. Okay, and so the sulfurs are good. Now the last thing is where we left off was with the oxygens. So remember, oxygens are in 2 different spots. Okay, so this 2 multiplies by this 3, giving me 6 oxygens. But I can't forget this oxygen here. 8 times 2 is 16. So once I do that, that's going to give me a total of 16 plus 6, 22 oxygens. All right, if I look over here, oxygen, I only have 2. But here's a great thing about it. I can multiply it by something to make it 22. So if I put an 11, that gives me 22. Now if you check everything in this equation, you're going to notice that it's balanced. So my coefficients will be 4, 11, 2, and 8. All right, so we've got the problem that you guys are actually, or the equation that you're actually trying to do on today's assignment. So we have aluminum hydroxide reacts with hydrogen sulfate to produce aluminum sulfate and water. So you kind of simplify it a little bit better, where you just put the symbols for the ands and the produces and all that by replacing them with pluses or arrows. So now we have this, and if you notice, I've already indicated if it's ionic. Really, if I look at the first one, the fact that I see that aluminum is a metal, right offhand I know it's ionic. For the next one, you see that hydrogen is not a metal, but you'll see sulfate. And when you see anything that ends in ate or ite or ate and ite, you know that it's going to be ionic. And then we look at the next one. Same thing I said. Well, here it is, aluminum. It's a metal, ends in ate, so definitely ionic. And then we know that water is covalent. So we're going to go ahead and you would have to look up the symbols and the charges on the resource folder that I provided for you on Schoology. It's not something that you would know by memory. You can even look it up on the internet. But I'm going to go ahead and look at the ions for these substances that I'm putting together. So first and foremost, let's go ahead and start with aluminum hydroxide. So the first thing I'm going to do is look up aluminum. So aluminum is Al with a positive 3 charge. Again, looking it up. If I look up hydroxide, it's capital O, capital H with a negative 1. So now I'm just going to simply crisscross the values in the charges, the number values. Remember, we don't show ones ever in chemistry, so it's just Al. Don't show the 1. And then this 3 that we crisscrossed, well, we crisscrossed it to a polyatomic ion. If you remember from the lessons last semester, you have to put them in parentheses. And so you're going to put parentheses OH parentheses 3. So for the next one, it says hydrogen sulfate. So I'm going to look up hydrogen. It's a +1 charge. And then I look up sulfate, which is capital S, capital O, subscript 4, and then a -2 charge. So I'm going to take the number values, crisscross them. Anytime I'm crisscrossing the 1, really, I'm not going to do anything with that. I'm not even going to show it, so really nothing happens. The 2, I'm going to crisscross it over here. But since this is not a polyatomic ion, we don't need any type of parentheses. So it's just H2, SO4. And then we do have the arrow that's already there. And then we have aluminum, which we already know is Al +3. We have sulfate, capital S, capital O, subscript 4, and -2 charge. Crisscross those. Okay, notice I'm crisscrossing the number greater than 1 into a polyatomic ion. So I'm going to put in parentheses, put the 3 outside. Then the 2 gets crisscrossed, but aluminum is not, again, a polyatomic ion, so it just stays the same way. So this is Al2 parentheses SO4 parentheses 3. And then water, I think everybody just knows that water is H2O. All right, we're going to go ahead and balance this. So I'm going to put the little lines in front of the compounds just so that I can indicate where I'm going to put those coefficients. So if I look at this, I'm going to start off with the metals, which is aluminum. I notice that here's my arrow, so this is kind of the halfway line of where my reactants are, which I'll go ahead and indicate with an R, and where my products are, which I'll indicate with a P. Notice that I have 2 aluminums. So I'm just going to write this down. I have 2 aluminums. So if I look over here, there's not a number next to the aluminum, so it's understood as 1. Now, what can I multiply by 1 to make it 2? I can definitely put a 2. This 2 will multiply by that 1 aluminum, making it now 2 aluminums and balancing just the aluminums. Okay, the next thing I'm going to look for, if I don't have any more metals, which I don't, is the nonmetals, and I have a S for sulfur. But notice that I have a common ion on both sides of the equation. I have sulfate, the sulfate ion that we used, right? So if I look at this, there's a sulfate ion is made up of a sulfur and 4 oxygens, right? And so if I look at how many sulfate ions I have here, I only have 1. And let me go ahead and just quickly circle that. But if you look over here on the side of the products, notice that there's a subscript 3 outside the parentheses. So if I'm going to write this down, I'm going to say, okay, well, in the side of my products, I have 3 sulfates because that's indicated with this subscript. I only have 1 on the side of the reactants, so I'm just going to say for sulfate on the side of the reactants, I have 1. So the question is, what can I multiply by this sulfate to make it 3? And I would put a coefficient of 3. And when I do that, now I can say, you know what? I have 3 sulfates. Okay. Now that we've done that, we're going to go ahead and balance off the hydrogens. So here, the hydrogens are in 2 separate areas. And on the side of the reactant, or the products, I'm sorry, the hydrogen is in 1 area. So I'm going to go ahead and just first find out how many hydrogens do I have on the side of my reactants. Okay, so there's this 2, and this 2 will distribute because we're using it, right? So it will multiply with that 3. 2 times 3 is 6. And so that now 6 will multiply against the 1 that's in hydrogen, right? So that would give me 6 hydrogens. But don't forget that I also have a hydrogen in here, so the coefficient of 3 times 2, that gives me 6 more, right? So then, since that gives me 6 more, I have a total of 12 hydrogens. So the question is over here, how can I make that into 12 hydrogens? Okay, so I currently have 2. What can I multiply by 2 to make it 12? Well, I can put a 6 because now 6 times 2 is 12. So now I also have 12 hydrogens on the side of my products, right? So now the last thing is that lone oxygen. So remember that we still have this oxygen, which I'm going to go ahead and probably go over it in a different color, but here's in the one of the oxygens here. Remember here we took care of it by using the sulfate ion, so we don't worry about that one. Here this is part of the sulfate ion, so we don't worry about that one, but we do have to worry about it right here. Okay, so if we look at the lone oxygen, okay, that 2, remember, will multiply by that 3, which gave it 6. Remember that 6 is now going to multiply times a 1 for oxygen. So that gives us 6 oxygens. And over here, we already had a 6 as a coefficient, which multiplies by the 1 in oxygen. And it also makes it 6. Okay, so there's our balanced equation. We pretty much have it balanced, and for a coefficient, that would just be 1. So if you balance this correctly, you would notice that you would have the coefficients of 2, 3, 1, and 6. And again, I can't stress enough how important it is to have this right, because otherwise you won't be able to do the assignment. Okay, so the next problem, following along the same equation that you just finished balancing, you're going to go ahead and use that information on the equation to create your ratios. So if you're reading the question, it says how many moles of aluminum hydroxide. So first and foremost, it's talking about aluminum hydroxide. If you all forgot what that was, remember part of today's lesson earlier was to create that into an actual formula. And we know that aluminum hydroxide is going to be the Al parentheses OH parentheses 3. Okay, can be reacted with 5.13 moles of hydrogen sulfate. And again, if you remember what that one was that you just did, it is the H2SO4 hydrogen sulfate. Okay, so notice that those are the 2 that were mentioned in the question. So aluminum hydroxide and hydrogen sulfate. So what we're going to do is make a fraction or a ratio out of it. So it says write the ratios that you would use in this question. So we're only going to use the ones that involve what's written in the question. So aluminum hydroxide, here it is, right there. So I'm going to go ahead and circle it because that's the one of the ones we're going to use. And then hydrogen sulfate, it is right here. So I'm going to circle that one. Okay, so how do we make a ratio out of this? It's actually pretty simple. Once you figure out and you see which one is used or which 2 are used in the question, then you put it like a little fraction. So the 2 from the coefficient that you decided would balance it. For aluminum hydroxide, you would write 2 moles. That's the only really different thing you're putting down, is you're putting the word mole or the abbreviation for mole. And then Al parentheses OH3. And the other one that was mentioned was H2SO4, so we know that we balanced it with the coefficient of 3. So 3 moles of H2SO4. Okay, the or part is just pretty much flipping that ratio. So all I'm going to do is just flip it around, because now that's going to give me a choice on what I could possibly use in our equation. Okay, so now that we have it down, our first step with anything that we're doing with dimensional analysis or stoichiometry, it's going to be to write down the given. So let's go ahead and take a look at what the given is. And if you notice, the given is 5.13 moles of hydrogen sulfate, which right now I'm circling in yellow. Okay, so I'm going to go ahead and write down in my given 5.13 moles of H2SO4. Okay, remember that every time we've done dimensional analysis, nothing goes there. Okay, now that we've put our given, our next step, we're actually going to give it a name. We're going to call it ratios. So for a mole-to-mole problem, which is what we're doing, it's the easiest of stoichiometry. So mole-to-mole problem, just know that you have two steps. Step 1 is your given, and step 2 is your ratios. Okay, so now that I've put my given, you're going to take a look at what unit and substance is in your given. Notice it says moles of H2SO4. So we actually want moles of H2SO4 to be on the bottom. So if I ask you which one would you want to pick, option 1 or option 2, then you're going to say that you're going to want to pick option 1. Why? Because it's the one that would be have moles of H2SO4 on the bottom. So therefore, I'm going to go ahead and write it down just the way I see it. 2 moles of aluminum hydroxide, just like that, and 3 moles of H2SO4. Okay, now that you notice that this will match this, you can cancel them. And all we have to do is the math. So for the math, it's going to be the 2 top numbers, which I'll go ahead and kind of box in red. So it's going to be 5.13 multiplied by the number that's next to it times 2. And those 2, when you get your answer, you're going to divide by 3. So here's what you're really looking at. 5.13 times 2 divided by 3. All right, so once I put in the calculator, my answer is 3.42. I always want to make sure that I put the unit and the substance that I'm working with. So the only thing that I didn't cancel is this one, and it's going to go there as my unit and my substance. So it's going to be moles of Al, parentheses, OH, parentheses 3. And that's how you would do that one. And it would be done and ready to go. Okay, so obviously if you're still watching the video, you're probably wanting to see how we do the next one. And I'll go ahead and work that with you. Or if you want to go ahead and stop the video and do it yourself first and see if you can do this on your own, and then you can check your answer by continuing with the video. But let's go ahead and take a look at number 3. It says calculate the number of moles of water that are created when reacting 3.97 moles of aluminum hydroxide. Okay, so just like we did it the time before, you're going to go ahead and find the 2 substances. So we're working with water. That is one of the substances, and the other substance is aluminum hydroxide. So because those are the ones that are mentioned in the question, you're going to find those in the reaction or the equation that you wrote. So for sure, here's our water. Remember, we have 6 moles of water, and we have 2 moles of aluminum hydroxide. Again, why did I pick those? Because those were the ones that were mentioned in the problem. Now that I have those, I'm going to create the ratio. So 2 moles of aluminum hydroxide, and that's going to be over the 6 moles of water. And then you obviously just have to put them, flip them around. So you can have your other option as to how you would possibly write that. Okay, so our first step for any mole-to-mole problem is always our given. So first step, and the second step is always our ratios. And don't forget that nothing ever goes underneath the given. So our given is the only number in the problem, and you have to write everything, okay? So you've got to write the number, which is 3.97. And then don't forget to write the unit, which is moles. And last but not least, don't forget to write moles of what? So in this case, of aluminum hydroxide, because that's what it says there. Okay, now that I have my given taken care of, I've got to pick from my ratio. Don't forget that you're going to pick which one goes on the bottom based on what the given is. So since the given is moles of aluminum hydroxide, that's what I want to pick, the one that has moles of aluminum hydroxide on the bottom. So I'm going to go ahead and pick the second option. So I'm going to write 6 moles of water over 2 moles of aluminum hydroxide. Okay, once I do that, I can very easily just cancel the units, moles of aluminum hydroxide with moles, and now all I have to do is take the top number, so the 3.97, multiply it by 6, and then divide it by 2. So just so you know what it looks like, numerically, 3.97 times 6 divided by 2. Because I trust that you can do the rest of the problem, you can go ahead and calculate it on your own. And that's already, I think, a good start as to what you need to do and how you could do the rest.